In part 2 of the topic on bottom slope forces, we will discuss when the foundation is below the anchor. This will be a more qualitative discussion because the math itself for the sliding is going to be no different than the math we've done in part 1. Remember, we're assuming a compressive strut. That is, the anchor is going to use the ramp walls and fill to push the entire abutment uphill if due to cable forces. We also have to assume a tension strut, which means the ramp walls and foundation, if on a downward slope, are going to pull the anchor downhill. Now, you may remember in the past, if the ramp walls hit the top foundation, we don't count the foundation weight because we don't want to account for that connection to hold all of the sliding force. And what that would look like is if we have a foundation slightly below our anchor, sometimes we will keep a horizontal bottom of that ramp wall. Obviously not to scale, but we'll keep a horizontal bottom of the ramp wall here in order to make sure that the ramp walls aren't pulling down on that anchor. And because of that, we'll just discount this, the part of the tiers, aka in this case the foundation. We won't count that weight for resist sliding because we don't want to rely on this connection right here. Now, also in the past, in part 1, we used 50% of those downhill forces, of those bottom slope forces, to be more conservative. But for part 2, because it would be more conservative to assume all of the force is pulling the anchor downward, we're going to assume 100% of those forces. So make sure you don't make that mistake when you are checking to see if you are checking to see if a sloped bottom of your ramp wall is going to cause a failure of the sliding factor of safety. Now, in general, we're going to want to avoid this downhill slope. And here's an example of abutment that has a very steep downhill slope. We're going to want to avoid this only when there's a severe backfill slope and the abutment is as short as possible, causing at least over 3 meters of excavation to be necessary for the anchor. If there is not a sleep, bring your bottom of your ramp wall to the top of the foundation, like shown above. Or even slightly higher, and then fill that space with an excavation bench. So something that we wouldn't do in this case, because we do have the case where we have such a steep slope on the abutment that if the anchor was down here, we'd have almost, as just to get based on that 160, we'd have almost 5 meters of excavation we need to do. And with benching, that would be nearly impossible. So one strategy for a less steep bottom slope is to either run it to the top of the foundation or run it horizontal. Here, I'll use a different color. Run it completely horizontal. And then where that benching is going to occur for the foundation, we'll just backfill. Make sure to specify that backfill needs to be done with abutment fill, so stones and mortar, or stones and grout fill. But in this case, like I said, we have such a steep slope here that there needs to be another solution. And we're not going to be able to just bring a straight line from the anchor, because we're going to neglect almost all of our weight in tiers. So if you do need a backfill slope, the solution is to step downward instead of keeping a continuous sloping ramp wall. Think a bit about this as sitting on a slide versus sitting on the stairs. Here's an example of um, that same design that was then converted into using steps. And like I said, you can think about this as sitting on a slide versus sitting on the stairs. Generally, sitting on the stairs, you're going to stay in the same place. Sitting on a slide, you're going to want to slide downward. Now, there are some empirical rules that we have while doing this. Once again, you want to maintain this dimension as greater than 30 centimeters from the topsoil. This sounds familiar, right? As a general rule, we don't want to trust that top 30 centimeters of soil to have any capacity. So we want our steps to be below at least 30 centimeters below the ground. As well, we do have, this creates more problems with, now that our sliding factor of is most likely going to be met, we have a problem with our soil shear failure. As you can imagine, the forces in this direction are going to want those those soil steps to fail in the same way that creating that same slope that we're trying to avoid by creating the steps. So in the next lectures, I will talk about soil shear failure in the general sense, and I will talk about it for a upward sloping or a positive slope and a negative slope bottom of ramp wall. For now, this is what you'll want to do if your team absolutely needs to have such a steep slope from the anchor to the foundation. We're going to want to think about steps as our first choice.